Alright, hello everyone. It is Wednesday, and you guys have a Chromebook. We're going to do some learning about volumes today, volumes of prisms. So this might be review for some of you guys, and for some it might have been a while since you've seen this. That's okay. We'll go through it, take our time. Everybody in the Smith house is doing well, and I can show you guys a pic or two of my new baby Asher. His name's Asher tomorrow. But anyway, let's get down to today's stuff. So we are talking about volume of prisms today. But first we have to kind of talk about what is volume. And I like to think of it as the amount of 3D space an object takes up. And the word you can think maybe of that is like capacity, because like capacity refers to like a cup holding water in it, and the more capacity it has, the more stuff you can put in it. A prism, because today we're going to be just doing the volume of certain prisms. A prism is a 3D shape with two identical parallel sides. So that's important, and we'll look at some examples of prisms. The identical parallel sides are important, and we'll look at some different types of prisms today. Just talk about what makes them prisms. And the big idea for today that we'll be using to find volumes, and you guys should have your formula sheet ready. The big idea is this. The volume of prism, the volume, and I might just actually use some little subscripts here. The volume of a prism is very simple to find. You find the area of the prism's base, and you times it by the height of the prism. That's the big idea for today that we're going to use over and over. And if you guys have a look at your formula sheet on the side we haven't been using yet, you have a bunch of formulas for different prisms and different volumes, and you can see for each of the prisms they have this in there. Volume of prism is area of base times the height. Now depending on the shape, there's some, because we have some nice tidy formulas for areas. For some of these volumes, we get a very nice, tidy formula that we can use, and we will use. Let's actually give our first example a go. So your first one, in my screen here, it's a lot bigger than on your screen, but the first example we're going to look at is a rectangular prism. So I've drawn an example of a rectangular prism, and mine's a Fruit Loop box. Rectangular prism. So you can see it's a prism because if you look at the top and you look at the bottom, they are the exact same shape. They're both rectangles, they're identical in every way, and they're parallel to each other. Like if you extended them, they would never meet. So two parallel, identical sides. Whoops, let's go back to this guy. There we go. Alright, now let's find our first volume. If you guys look at your formula sheet, you guys are going to see the following. You'll see the formula area of base times height. I might shorten it. But we're going to use the nice tidy versions of those formulas. For a rectangular prism, well guys, the area of a rectangle is just length times width, right? So the area of the base is length times width, and the height of the prism we call h. And then that's the formula that you guys see in your formula sheet. And it's a really easy formula to use. And it comes from area base times the height. Length times width times height. So we're going to just make up a few numbers for our measurements. So why don't we say a Fruit Loop box, let's say has 5 centimeters for one dimension, let's make this, how about 30 centimeters for that dimension, the length of the base there. And then let's say, I don't know, 40 centimeters. I'm just making things up so we can do an example here. So I'm going to use that to find the volume of this Fruit Loop box. So we've got our formula, and then we just plug in what we know. We can use, why don't we use L and W for the length and width of our rectangle base, and we can use 40 for the height of our prism. So 30 times 5 times 40, really quick and straightforward for us to calculate that. You guys should do it too, but we should get 6,000 centimeters cubed. So you should definitely try that on your calculator, but rectangular prism, very easy to find the volume. Alright, let's go on to our next example. We're going to find the volume of a triangular prism. So triangular prism, and so this maybe looks like a ramp that, you know, the kids at the park by my house made a little improvised cardboard ramp. Might look like that kind of thing. This is a triangular prism because the base, it's a triangular prism. The base of this prism is a triangle. So we have a base here and then a base on the back. And what I want to really emphasize is when we refer to the height of a triangular prism, it's like the height connecting those two the bases, those identical triangles. We're going to look at the formula, and just like for a rectangular prism, for any prism, the volume is the area of the base, so I use that A with a little subscript base, times the height of the prism. Now, because you're dealing with a triangle, we want to make sure we differentiate between the height of the prism and the height of the triangle that makes up the base of the prism. So your formula sheet has labels like this. You guys will see a B for the triangle base, and you guys will see an L for the triangle base too, and the height of the prism they call an H. Now the one on your formula sheet looks a bit different, but you should see a B, an L, and an H there, and that's where this formula comes from. So you guys will see in that formula sheet in the box, you have this formula. You have base times L times H all divided by 2. And it's not like it's not out of thin air like just a magic formula. It just comes from the fact that the area of the triangle base is just base times the height of the triangle, which on your sheet is labeled with an L, times divided by 2, and then you times by the height of the prism. And it's a really easy formula to use too, almost like rectangular prism. You just multiply 3 numbers together and then divide by 2. Really easy to use, and that makes sense because if you can kind of visualize this, if you could visualize like making another copy, flipping it over and putting it on top, it actually would make a rectangular prism, right? But anyway, let's choose some measurements for this guy. So let's use I'll try to make things kind of to scale. So why don't we use, how about 20 meters for that side? Let's use maybe, this almost looks like half, so 10 meters for that dimension, and let's use 15 centimeters for the height. And let's just do a quick calculation on that. Really easy. Again, it's just 20. So base times length, which we said was 10, times the height, which we said was 15, just like rectangular prism. Then you just divide by 2, right? And some of us prefer to write that as divided by 2 on the end, which is just fine. That's no problem. So you guys should do that too, and you can verify, should get 1,500 meters squared. So that's the volume of a second type of prism, and it's really easy to use if you have the height of the prism and then the triangle base. Just find the area of base times length times height divided by 2. The last prism we'll find volumes for today is a cylinder. So a cylinder is basically, it's a prism too. It's just the base is a circle, and we don't actually use the term circular prism. We just use the term cylinder. And its volume, again, is area of base times the height. This time the base is a circle. So you guys will see in your formula sheet for a cylinder, the volume is pi r squared, because that's the area of the circle base. But for a cylinder, it's a prism. To find the volume, you also multiply by the height. Really straightforward. We can all do it. And some of us who are quite comfortable with our exponents may prefer to just write it out like this. That means pi times the radius again times the height. So I've drawn a Campbell soup can for an example for us to use. Let's pick up some measurements for this guy, and then we'll find its volume. So let's make it a fairly small soup can. How about 10 centimeters tall? And just to make it to scale here, why don't we choose, I don't know, how about a radius of 4 centimeters? I have no idea if that's what an actual can looks like. We're just trying out some things. Just getting used to the calculation. So for us, the volume, I think what will be helpful for a lot of people is to use this version where you take pi times the radius again, that's the radius squared, that's this right here, 4 times 4, and then times the height, which is 10. And this is easy to calculate volume too, right? It's just multiplication. What I think you guys will find the most challenging is just choosing, not so much identifying what shape it is, but just saying, okay, this is this measurement, this is the radius, this is the height, especially with the triangular prism. You guys should hammer that in, and I got 502.4, and the units, I think I have talked about this, but let's just make sure we talk about units. Since volume is a 3D concept, the units are centimeters cubed. So if you can imagine a little sugar cube, in this case, a little cube of sugar, maybe 1 centimeter, 1 centimeter, 1 centimeter, 500 of those would fit in this Campbell's soup can. Just over 500 of them. So that's what I want you guys to be able to do from today. And if you need to pause and rewatch those videos and try them over again, that's fine too, but I want you guys to be able to find volume of these 3 kind of basic prisms: rectangular prism, triangular prism, and a cylinder. I want to do just a couple problem solving questions with you guys. This one, first one, it's pretty straightforward, but I want to tie in just some problem solving, maybe a bit of thinking from a previous math course, just tie in some numeracy things as well. So in this question, I've given you guys a box of crackers, and let's actually imagine that the height of the prism is like that dimension, that long side. It's almost like tilted on its side. I've told you guys that the, actually, you know what, let's use, I'm actually going to scratch that, just because of the way the question is set up. Let's use, for this particular one, we have the length is 25. Let's stick to what we know, because I think this matches up well with the dimensions in the question. 25 centimeters for that cracker dimension, and then this side of the cracker box, 8 centimeters. And in this question, we actually know the volume. We know how much the volume is, but we're going to find, what we want to actually know is, well, how tall is this cracker box? That's the question. Because you know what, guys, it's pretty easy just to calculate length times width times height. It's not really that hard to do with your calculators. This is a neat kind of question. So let's look at it this way. You guys do this as well. If you guys write down volume equals length times width times height, what we know in this particular problem is that The volume is 2,000. The length, we said, was 25. The width was 8. But in this question, we don't know what the height is. So I want you guys, can you actually just write down height with me there as well? Just leave it as h, because we actually don't know what it is. If you guys just do 25 times 8, can you do that? Just hammer in 25 times 8. And again, you can always pause and rewind and restart the video as you need to. But 25 times 8 gives us 200. 200 times whatever the height is going to give us our volume. So think of it this way. 200 times what number? Because that gives us that 2,000 volume that we need. Now, some of you guys can use mental math to do this. Some of you guys might need to rely on some skills from earlier grades. You can think about this as finding the height. Think about it instead of multiplication. Think about division. Another way of answering that question is, hey, well, the height must be 2,000 divided by whatever 200. Divided by 200. That should give me my height. That's just another way of writing that. 2,000 equals 200 times h. And that works out nice and evenly to 10 centimeters. The height of the box is 10 centimeters. We'll do a few more questions like that, but I thought it was just a little bit more of a challenge, because it's pretty easy just to plug in length times width times height all the time. We can all do that fairly easily. But that's a bit more of a challenge problem. I thought it'd be fun to do with you guys. Alright, you guys are doing great. I want to do one last question with you guys. And it's actually a question to do with a prism that doesn't actually have, it's not a rectangular prism, it's not a triangular prism, and it's not a cylinder either. Because if you guys look at the base of this like special Toblerone bar, it's like basically 6 Toblerone bars all kind of packaged together. But look, the base is a hexagon. The base, this prism isn't one of the things we've talked about. So I don't want you guys, when you see this question, to think, oh, I can't do it because it's not in any of the things I know. Because if we just remember the real key idea for today, and that this is where all those specific formulas come from, for any prism, the volume is area of base times the height. And I've actually given us the area of that base. The area of the whole base here is 140 centimeters squared. It doesn't matter what shape it is. I've told you that's its area. And the height, connecting those two bases, is 35 centimeters. So we can very quickly actually figure out the volume of this Toblerone bar. The area of the base is 140 centimeters squared. The height is 35 centimeters. And if we just crank that out, I got 4,900 centimeters cubed of chocolate. So I just wanted to throw a question like that at you guys too, just to see if we can do any prism, even ones that have a hexagon base, like this guy, by using area of base times height. Let's finish off. I thought it'd be interesting to actually, because like not everybody can visualize like how much chocolate that is, the centimeters cubed. But if we think about it another way, if we were to melt that and like drink this Toblerone bar, how many liters? Because everybody knows what like a liter or 2 of milk looks like. A liter of milk is like 1,000 of these centimeters cubed. So our Toblerone bar was 4,900 centimeters cubed. 1,000 centimeters cubed is 1 liter. So if we divide that by 1,000, we get 4.9 liters. Liters are just another way to express volume, and that's where it comes from. A liter is just a liter is 1,000 of those centimeters cubed. 4.9 liters. So kind of a little silly question, because like think of 4.9 liters. Like when you buy bags of milk, I think you can't even buy more than 4 liters at a time. That's like drinking that much chocolate. So it's pretty crazy. But I thought that would just be fun to just wrap our minds around how big that chocolate bar is. Okay, so you guys will have a practice sheet finding some volumes, And I know you guys have been doing a lot of stuff without me this week. Tomorrow I'll be back. We'll focus on just reviewing the things you guys did, having time to wrap up some assignments, especially the perimeter one that you guys got on Tuesday, and just making sure that everything's good, doing some more examples together. So don't worry, we're going to make sure that everybody's good, but hopefully you guys are doing your part and taking down the note and trying your practice as best you can. And as long as you're doing your best, that's all I can ask, okay? So have a great day, and I will see you guys